less as a scary math problem and more like a secret code, a code that we are about to break. Alright, so before we can solve anything, we've got to understand the puzzle itself. What are we actually trying to do here? Our mission, should we choose to accept it, is to find the roots of this polynomial. Now think of roots as secret keys. When you find one of these special numbers and plug it into all those x spots in our equation, the entire thing just collapses all the way down to zero. That's how you know you've found a solution.
Every good detective needs a plan, right? We can't just start guessing random numbers. We're going to use a systematic search, kind of like a police lineup, to hunt for these roots and check our suspects one by one.
And our method is super straightforward. It's just a 3-step process. First, we pick a number to test. We'll just call it k. Second, we plug that number into our giant equation and let the calculator do the heavy lifting. And third, we check the final result. If it's 0, we found a root. Simple as that.
So, where do we start our search? Well, to keep things simple, we're going to line up our first few suspects, the integers from 0 all the way up to 6. Let's see if any of these guys can unlock the code for us.
All right, the prep work is done. It's time to roll up our sleeves and actually run the numbers. Let's start testing our values one by one and see what we find.
We'll kick things off with 0. It's usually the simplest one to check. If we plug in 0 for x, almost everything just vanishes. And the result is 66, so not 0. Our first suspect is cleared. 0 is not a root. On to the next one.
Okay, how about the number 1? Let's plug it in and see if 1 is our first secret key.
And bingo, we got a hit. The result is 0. That means we found our very first root. The number 1 is a solution. That's one key down. We found 1, but are there more? The investigation continues. What happens when we test the number 2? Wow, look at that, another one, right away. 2 is also a root. So see, this is the thing. We're not just looking for one solution. There could be a bunch of them. This is getting pretty interesting.
All right, we're on a hot streak now. Let's see if the number 3 keeps this pattern going.
And the streak is broken. The result is 196. So 3 is a dead end. But that's okay. It proves our system works for ruling things out, too. Next up on the list is 4. Is this going to get us back on track? Yes, we are back in business. 4 gives us a result of 0, which means we have found our third root, another key for our collection. We're really building some momentum now. What does the number 5 have in store for us? Incredible! 0 again. It's almost surprising how many of these are working, right? The number 5 is officially our fourth root. This is it, the last number in our initial lineup. Let's see if 6 can finish us off with another win. And there it is, a perfect 0. The number 6 is also a root, which gives us a grand total of 5 successful hits from our little search. Not bad at all.
We've run all the tests, and now it is time for the big reveal. Let's lay out all our clues and see exactly what our investigation has uncovered. You know, seeing it all laid out like this really shows you how well our system worked. We tested 7 numbers, got 2 misses, but an incredible 5 hits. This simple process of just test and check has revealed 5 different solutions to that really complex equation.
And there they are, the keys to our puzzle, the 5 numbers that solve the whole thing. 1, 2, 4, 5, and 6. We cracked the code. Now, a 6-degree polynomial can have up to 6 roots, and we found 5 of them with this simple method. That's a huge success.
So we found the answers using our step-by-step method. But in math, just like in detective work, there's often more than one way to crack a case. And there are actually a couple of other really clever ways to solve this. For example, one advanced technique involves looking for patterns to factor and simplify the polynomial, kind of like breaking a giant problem down into smaller bite-sized pieces. Another one uses a clever substitution trick to transform the entire equation into something way simpler. We're not going to go through all those steps today, but it's a great reminder that for any tough problem, there are often multiple.
But by applying a simple, logical system, test, calculate, check, we found the answers. It kind of makes you wonder, when you're facing any kind of daunting problem, is the key not some kind of hidden genius, but simply having a good system? Thanks for cracking the code with me.